All right, so this is the forward enterprise UI. So essentially what we're going to do is we're going to step through some of the use cases that Matt had spoken about, and we're going to protect some of the innocent in here and show you, hey, if something similar were to happen, this is how Forward Enterprise would be able to help you identify the situation so then you can can in turn remediate the situation. So let's look at the move it breach. So how can we ensure all the time that specific ports aren't allowed into the network, right? So you modify firewall rules, you may have tools that do it, but how often will they trigger? How often will things happen? So for instance, if we wanted to see a specific, so we're going to go from a specific internet facing IP address. And if I knew how to write an IP address, I'd be a better person this morning.
As long as it's not more than 255.
Exactly. East Coast time is still in my head. So we're going to go to a destination IP address of a web-facing VIP, and we want to look for a layer 4 destination port that is not equal to port 443. So essentially what I want to know is what can hit this VIP that's not port 443 and is delivered.
So the idea is, we only want secure traffic, whatever it might be. So let's see what other things might be connected. I had a VIP. I mean, I'm not a networking guy. Super deep virtual IP, just for folks that are like me.
So we can see that it comes in from the internet, bounces around a couple of firewalls, hits a load balancer, and gets delivered to the end destination. But why? We should see nothing here because nothing to this virtual IP should be able to hit on port 443. So if we check out our edge firewall, we see that we've hit a layer 4 destination port of port 22 that's allowed. So this could have been done from a change in the past or a nefarious actor inside of the network who's trying to expose a service that a service shouldn't be exposed. So now how can we repeatedly check this without coming to the forward UI and typing in this path search or saving the path search and just pasting it back in over and over and over again? What we can do is we can save it as an intent check. So essentially what we're doing is every time a network snapshot is taken, we gather all the running config, we gather all the state, and we put it through our mathematical model, and this is how we come up with what we have. So we can look for an existence check. So is there at least one path? An isolation check, is there no paths? Or is there reachability between the two? So we're going to define this as an isolation check. It brings the path view back up again. If you wanted to add more items to it, you could at this point. And then we could name it. So we want to do only HTTPS to VIP1. We can tag it if we wanted to tag it. We can set the priority. So when we do alert, so alerting is an email, or we have an integration with ServiceNow, where if this did violate, a ticket would be spawned in ServiceNow. So it can be triaged by appropriate teams. So we come in, we click create.
I'm going to forgive your name there. It's missing a P, but.
Thank you. Again, East Coast time, not used to West Coast time. So now we actually went and created the intent. So now we have an intent check that will run every time we have a collection. So as we can see, we all know this failed. But let's look at one that we have that can show more information. So if we look at this web only, we see we have a pass. So this has actually been checkpointed a few times. So you can see there was a point in time where it did pass. But what we'll also show you is we'll show you the state of the devices that have changed, what caused that state change, and then you can come in and go, okay, on this firewall, for instance, if I'm like scrolling through it all, we didn't have SSH before. Now we have SSH now. And then you can go back and say, okay, at this time slice, what was the change that was done? Why was this done here? Typically, right, may not be for nefarious purposes. It could be a shared object group that maybe the person who was doing the work didn't really do his or her due diligence to figure it out. But this is one way where we can proactively go through and at every snapshot, make sure that the intent of your network has not changed at all. The second piece of that, what Matt was talking about, is exposure. So today, if I asked you guys, can you tell me every device a single workstation can hit, would you be able to answer that? Yes or no? Probably not, right? So we integrate with Rapid7 and Tenable for this. So what we do is depending on the solution that you're actually working with, we make an API call and we pull back the information that we need. So we get the IP address, we get the vulnerable services, risk score, and critical vulnerabilities from Rapid7. What we do with the IP address is we compare it to what we know that's inside of our mathematical model, and we can place it where it should be by looking at MAC tables and ARP tables and know the switch port that it lives on. So for instance, if I wanted to look at this one IP address, 10.101.21.10, and if I clicked view blast radius, what it'll do is it'll give me a summary of where the device is, what port it's connected to, what VLAN, subnet, MAC, vendor, all that good information that you want, as well as extrapolating more on the vulnerabilities from, in this case, Rapid7. So it's 6 critical, 34 severe, 63 moderate. But that's not it. We show you the reachability that this specific host has access to, the protocols, the ports, app IDs, along with, we also overlay the vulnerable services too. And at any point in time, you can say, oh, this host has access. This guy's one of my critical servers. Let me look at a sample path. Let me see what's going on. So you can see the path that this flow would take. So you can see, oh, is there a firewall this is going through that I could potentially try to remediate something quicker? Or is there some kind of security device that he will go through where, again, remediation could be happening quicker, so you have time to go in and remediate that device?
I don't see a firewall in that flow.
No, there's no firewall in that flow. He's sitting alone in the corner over here.
That's too bad.
The other thing to point out with exposure is you can set the exposure point that you want. So right now we're looking at these 9 hosts are currently exposed to the internet. So you can change your exposure point to like a contractor's VPN, a DMZ, a partner's VPN. So you can always know what sections of your network and the users of those networks, what the exposure point can look like at any given point in time.
Hey, Mike, it's Evan here.
Hey,
Just a
Evan.
question for you. How are you getting the data into this?
By data, what data do you mean? Like the actual network data?
Yeah, the actual network data, the configurations, all that.
Yep. So we have a collector that sits on site. The collector can be in an active passive pair, and what it does is it reaches out to network devices, and it just runs a bunch of show commands, depending on the device, right? So we'll get a show run, and then depending on the device, we'll get a bunch of state information back. So at that snapshot time, we're going to gather that information, and then that's how we build this math model. If there's a question ever on security guys, hey, there's this black box that's just connecting into network devices. I want to know what commands are running. I just don't want some black box to randomly and arbitrarily start writing commands. In Forward's documentation, we list out the vendor, the model, and the commands that we use to build that part of the state, to build that model for that particular device.
Just want to layer on to that as well. We support a huge variety of vendors. So the idea is you might be able to get some of this information easily from one vendor, but how do you get this across every single vendor, every
multi-vendor environment?
We essentially, spent years and years researching and mapping that to our own language, which I don't want to spoil, Mike will get to, but essentially we've remapped it to our own language so that you can do really powerful processing across every device, regardless of what vendor it is.
So these are all, out of the box things. Like Matt was saying, later on down the line, I'm going to show you some of the cool things that you can do with our query language. But to answer your original question, we connect the device, we suck data in, that data is fully available to show, and then we build the model from that specific device from the data that we collect.
Hi, Mike. Rico speaking. Regarding the devices you are able to integrate, when you pitch, we try to track the packets. Are you able to also identify that you are missing data from some devices that you didn't know that was implemented, such as external web application firewall or additional load balancers that are not maybe under your control?
So what we'll do is when we suck in data, and if there's something that we didn't miss, when we go to build the model, we'll actually show a device and we'll say that it's not modeled by forward networks. And then if it is a device that you have control over, then you can then, however we need to get it added. The piggyback of that is if you're going into a like an MPLS cloud, right? Verizon, AT&T, they're not going to let you connect our platform into the system to be able to model their whole infrastructure, right? So we have this concept called a synthetic node, which that synthetic node would be, like the Verizon MPLS network or the AT&T MPLS network or the internet as a whole, per se.
This is Richard. Two quick questions for the folks that are watching that might not be familiar with your product. How are you logging into all of these devices? Do you have to set up users for them, local sign-on, or can you integrate with like Cisco TAC or AD into different devices and things like that?
So we integrate with integrate with external external identity providers. The one key piece to it though is we don't need a rewrite account. So you can provision us a read-only account. All we're doing is running show commands. And then essentially, depending on the device that we're connecting to. So let's look at a traditional network device, and then let's look at AWS, right?
And as an add-on to that question, what layers are you looking at in the OSI model? All of them?
We're going 2, 3, 4, and 7.
2, 3, 4, 7. All right.
So we will actually SSH into the box. We will run what we need to run to get the data for that specific box. AWS, we need a read-only IAM account. We connect to AWS's API. We run the API calls that we need to pull that information back to build the model. If you have an air-gapped environment that the forward collector can't get to, the forward collector understands jump hosts. So you can program it with jump hosts, and we can either SSH to the jump host and then have the jump host SSH to the end host, or we can treat it as an SSH tunnel and go right through the jump host to get to where we have to go.
Yeah, and just to add, so this platform that we've built can work only in cloud, it can work only on-prem, or it could work across both. So very flexible deployment options depending on the environment. And we also scale out to basically tons of devices, we'll just say.
Hey guys, this is Gerard here. This is my first time seeing you guys, so I'm super excited. The only quick question I had is when you're pulling all this data for exposure analysis and what CVs or vulnerabilities are out there, what's the time like from the vulnerability being released to the time from remediation? Like what is the response time as far as identifying it and then rectifying it?
So we don't do any rectifying. All we do is identify.
Okay, thank you.
Yeah, and I can speak a little bit about the timing. So, it'll largely depend on what vendor you're using, that database, how often that database is updated, for example. And then we also have creative ways. We'll say if, vendors are sometimes slow to write their own vulnerability reports, and so that gets propagated to NIST, that gets propagated to other vendors who want to identify it. We have a shortcut. If we know what the vulnerability is, maybe there's not a whole lot of data on it, but we know enough. We're able to build custom queries to actually look for that before anything is released. So it's almost like you might be the first one to react to a 0 days if you have enough info and can find it on your network before any other vendor can find it. So just to put that out there.
All right. Any other questions? Sweet.
Yeah. Excuse me,
Okay.
This is Kirsten. I also have a question. Did I get that right? You're also monitoring or can simulate things on layer 2, the switched layer of a network?
Yeah, so we can actually lay out from a path search layer 2 information, yes.
Okay, layer 2 information. So is it also possible to simulate the blast radius of misconfigurations in layer 2?
Blast radius of misconfigurations at layer 2. So that would be all
That would be a predefined intent check. So if you have an intent check that you want to look at, right, and you want to make sure that, for instance, I really can't even think of an example off the top of my head right now, right? But you can write a path search that says, hey, listen, ensure that there's no loops from this endpoint to this endpoint. That would be a intent check that would run every time a snapshot is taken, and that would be something that would be built. All right. Going on to the second one, good old MGM. So this kind of we're going to discuss now is how we look at posture. So coming from the consulting world, I had to do this more often than I would like to say, where I had to sit and audit firewalls on a daily basis. And then the data is only good until the next time that firewall was changed. So there was one point in time where I had to do an audit on 500 firewalls to make sure that PLC networks, so IoT networks, had the right segregation. And as I'd move on, I never knew what happened behind me, right? So there was this kind of disclaimer with the CTO where it's like, hey, listen, if I finish this group's data is only as good as today, because they can go back in and mess stuff up. So what we can do in Forward is we can build these posture matrices. So we can look at it on-prem. So we can do it between subnets devices and VRFs. We can do it in the cloud between cloud subnets and cloud security groups, as well as looking at it from a firewall standpoint, so looking from zone to zone on a firewall. So the one matrix you're looking at right now is a cloud security posture. So we can see in one of our AWS instances, we have a posture map set up where we're showing a nice color-coded graph of what can access what. So essentially what the color codes mean is the gray X means there's no route. Green arrow means there's full 100% connectivity. The red kind of look and stop at the door is blocked by an ACL, but the yellow one is partial access. So then you're like, okay, I'm more curious as to what this partial access potentially looks like. So when we click on it, it'll show you what that partial access looks like. It'll tell you the source IPs and the destination IPs, as well as ports and protocols. But it'll also show you a sample path of exactly how that packet is moved and how we came up with the determination that it is a partial match. So like I had said in the beginning of the presentation, I'm a network guy by heart. I started learning the cloud, and I'm still learning the cloud 15 years later. You don't need to be an AWS guru to understand what's going on, how we lay it out. You hit this VPC, then you go into this subnet, this route table, then we hit a transit gateway, and how it steps you through every single construct that it hits inside of AWS. So essentially, we're starting in the SSH access VPC. We jump to the transit gateway. We get policy routed to a firewall where there's a Palo Alto sitting there. And if we click on the Palo Alto, we can see exactly what it's doing. So if we didn't know that this was a Palo Alto, we give you the information that you need to make the decision on what's going on without having to worry about what vendor's behind the scenes. So you don't need to understand how Palo writes their config. You don't need to understand how Cisco writes their config. It's written in plain English that even a level 1 NOC, SOC, or help desk guy could potentially understand. And then from there, we break it down even further until the packet gets delivered. So now seeing is believing. So what we're going to do is we're going to create a posture map on the fly. So what we're going to do is we're going to create a posture map looking at our backup e-commerce infrastructure that's in our San Jose data center. So to do this, we're going to give it a name. So we're going to call it SJC Ecom Backup. We're not going to exclude any protocols, and we're going to leave the timeout as the default. So we're going to add a resource pool. What do we want to add? Do we want to add on-prem, cloud, or security zone? So we're going to do security zone. We're going to click next. It's going to pull up the firewalls that have specific security zones configured. So we're going to choose our San Jose one. And then as long as you name your zones correctly, and it's not zone 1, zone 2, zone 3, zone 4, we'll be able to come through and go, okay, I want to know dev zone, ecom prod, ecom QA, and anything from the internet that's coming in. I'm going to click done, make sure this all looks good, click add, and in the magic of 2 seconds, we have a posture map built that with every collection that we do will get updated if there's changes to it. So no longer do you have to go back and say, oh, that audit's coming back again. I have to go log into 500 more devices, do what I got to do, and then put that disclaimer. It's only as good as the last time I touched the device. So now we have this, lays it out, same color scheme as before, red no access, yellow partial access, green full access, and it's fully exportable. So you can export it out as a CSV doc, which doesn't look as pretty because it actually spells out partial and no access, full access. Or what I would like to do in this is just take a screenshot so you actually get the colors along with it.
Yeah, so this is super important for compliance. I mean, I'm sure a lot of you are part of organizations, might be NIST, ISO 27001, SOC 2. I mean, there's so many frameworks out there. Really, just quickly getting evidence is half the battle. And yeah, saving resources, saving time for network engineering is super important for compliance.
I was a very expensive consultant doing this, so yeah, they could have saved a ton of money by doing this. Now jumping into what we can do for vulnerabilities. So because we have all this rich data and rich network information that we have, so we download daily from NIST. And then what we do is we take what your estate looks like and we compare it to the NIST CVE database. And then we come up with what you see on the screen, where we can do a OS version match and we can even do a configuration version match. So let's start searching for one. So we don't need to know the full CVE ID. We can just start with whatever numbers that we know. So we're just going to search for 2241, which comes up with a critical Juniper match. And if we click on the view details, what it'll tell us is, you know, this is from Juniper's KB article saying, hey, this is what the vulnerability is. In your infrastructure, these are all the devices that are affected by it. And we even call out, does this device receive traffic from the internet or does this device carry traffic from the internet? Which is extremely important when you're dealing with some of these CVEs. So we lay it out, again, exportable via CSV file. And, you know, that's the OS version match. And, you know, to me, it's like, okay, we can do a OS version match. That's pretty cool. But what about a configuration-based match?
Let me just ask, though, I think for our audience here, how easy is it today to understand if a device is internet connected or not? Are you able to get...
It depends.
Yeah, it depends. Exactly. Some are going to be super easy and some are going to be super hard. And I think this essentially puts almost everything that you have into the easy bucket.
So now let's take a look for a configuration match. So for configuration matching, today we support a host of devices. So we support Juniper, Cisco, Arista, and Palo Alto, with more to come down the line. So if we're going to search, let's search 201.98.
This one is very familiar. Anyone familiar with this one on the call? CV 2023.
This is the 10, right?
It's a 10 out of 10.
Yep.
Right. Yep.
This one was this one like 2 weeks ago?
Yeah, this one was recent.
Yep.
Yeah. Okay.
Yeah, this was the iOS XE one with the browser ability.
Yeah, this one came out and everyone was like, oh, you know, like, what's going on here? Actually, a lot of it looked kind of like a hard-coded password at first. It was like, oh, Cisco installed a hard-coded backdoor and it's in every system. I think it turned out to be a little bit more complex than that. I think it was more of a privilege escalation vuln that had basically, you know, level 15, kind of the top level of access, but it was very easily exploitable all over the internet. And the funny thing is, you would think maybe a lot of these systems are protected, maybe intranet, not potentially exposed, but there were a lot of devices on the internet. And we looked at Shodan, a lot of basically internet scanners, and they're like, oh, wow, there's a lot of already infected devices out there today. This got heavily exploited.
Now, going to put my network engineer on hat for a second. You know, when I deploy Cisco devices, it's like I could have thousands of these geolocated across the world. How difficult would it be to figure out, if you know the line of configuration that's affected by it, how long would it take you to go into every device and figure out, oh, hey, listen, now all these devices are affected by it? With a click of a button, we can show you the devices that are affected. Again, call out that same receive traffic or carries traffic to the internet. And then we will show you the line of configuration or configurations that caused this vulnerability to fire. So now you have the tools in your hand to go and be like, all right, this group of XE devices or this group of any device is affected. And now I have the tool to be able to go back in to remediate the platform.
Yeah.
This is Richard. Does that compliance report update automatically once the change on the equipment has been made? Or do you have to rerun it again?
So it'll change when you take a new snapshot.
All right.
Yeah, and that'll be configurable based on your environment.
Yep. So snapshots are on demand. So you can schedule them or you can just run them whenever you want. You can do sub snapshots, so you can break out different work. So if like you were working on a specific set of devices and you don't want to snapshot the whole estate, you want to snapshot a small piece of the estate, you can do that as well too.
And let me just layer onto this example, because I think this is really important and also top of mind for a lot of organizations. Imagine you have 100 Cisco IOS XE devices, right? If you don't have this data and you see a CVSS 10, what is the default? The default is drop everything, patch all 100 devices. That's kind of the response, the typical response. And so with this layer of data, now you can put context that you wouldn't normally see. You can actually look down to the configuration level. So if this feature is not enabled on all these devices, guess what? They're going to be deprioritized. If it's not connected to the internet, well, that also might be deprioritized, maybe the next priority. But now you know essentially what the top area is. Instead of trying to patch 100, you only have to patch a handful. Maybe it's 5, maybe it's 10. But the idea is that creates less risk for the company, because now you can focus your efforts on patching it, testing it, and ensuring business continuity versus a fire drill of patching everything and then cleaning up the mess after.
So let's jump back to that Juniper one real quick. So
actually, Mike and team, if I may pause you right there. Regarding that Cisco one, right? So obviously that still had a vulnerable web server configured, but is your reporting taking into account if there's an ACL limiting exposure of that web interface to like a specific network management subnet, you know, where the network operators are sitting or where the tooling is originating from, where that vulnerability isn't exposed? Even if it's a switch or a router that may pass internet traffic, specifically that web UI is only accessible from an ACL DOF specific subnet. Is it taking into account that, or is it only looking for whether or not this line is found in the running configuration?
It's a good question. So I don't, as far as I know, we're not taking into account the web config. So that's a layer, and actually that's super hard to manage. So I'd be curious, if that is the norm, something that we could look into in the future. But we're really
familiar with other products who are doing that. But always the assumption of whatever the config shows, that's what we're going to report. Other products doing the same thing. I mean, there's no function of compensating controls as a built-in feature.
Yeah, and that's going to be, I mean, that might be a secondary protection. So let's just say you can drill down to the route level, right? That's going to take precedence. And then you can say, okay, well, maybe we don't have visibility for that web GUI, but we can look in and further drill down what we need to patch right away. Or, maybe it's nothing if everything is protected at that level. So yeah, I think that's a good nuance to call out. That you might have as an organization. Maybe you have restricted it even further. That's not visible at the network layer, but it would be at that web layer.
Yeah, and just to add on to that, because you guys, your product takes a snapshot of the entire network, including the firewalls. that may or may not sit in front of access to this device.
Yep.
Maybe the mitigating control is the firewall that sits in front of the access to that device. So while, yes, the service on the platform may actually have this vulnerability, the control or risk is mitigated or minimized down by the firewall that's controlling access to that web UI, from a secure network operations isolated subnet. Does it take into account something like that, or is that non-existent today?
Yeah, absolutely. So let me throw a question back, because I think a lot of people would be scared to make that configuration at the firewall level, because it's something that'll affect broader sets of access or things downstream. And so, changing it at the device level, or what is affected, is generally the way people, they know high fidelity that this is going to solve the issue right away. But yes, having that complete information of your network, being able to make a sound judgment and say, I know exactly how this network's configured. I want to change this firewall setting. I know exactly how it's going to affect downstream, is super important. And that is another path that you could take. And I think this data and the platform powers that decision to be confident in that decision.
Yeah, but I think that's what we meant by asking that is, again, trying to evaluate compensating controls in a sense of, you already know what's allowed and not allowed, higher in the, I would say, in the flow. So based on what you already know, and again, it's pretty clear that you have the entire route that, exposed to you, and you're able to see everything. So you are able to tell what's going to come through and what would be blocked based on that. So if you already give it a score and you know that it's not going to pass based on your model, that I think can be translated into a score or something that would say, yes, it is important. It is high priority to go and fix it because it's a significant vulnerability. However, your current setup is not allowing that type of access to the device unless it's being done directly, outside from the internet.
Yeah, so it would be something that could be called out in this pane when we see the list of devices, right? Like, yes, it is affected by this specific CVE, but there's a mitigating device in front of it that's configured to be able to do that.
Yeah, but not us trying to figure out based on what we're seeing here, just having something that is very clear, right? When you show that summary, here's what you need to deal with first, can deal with the rest of it later.
Yep.
Hey guys, this is Martin Knutson. This is what I've been this level of conversation is kind of what I've been waiting for. You've got a lot of the information. So when I think about vulnerability management, I try to think more about the risk management, because it's not about, oh, we have to go fix all of our 10s before we fix our 7s, even though that 7's sitting on the internet. So we've kind of established you've got the information, or at least some of that information here. And it's laid out well in this view. Do you take that to the next level though? Like, do you do hey, we know all this information about your network, and here's the riskiest situation that you should go address right now, rather than having to be, okay, there's this 10, let's go look at what is affected by that 10, instead of saying, hey, there's a 7 that's out on the internet, go fix that now, don't worry about that 10 yet. Does that make sense?
Yeah. So
you mean like prioritizing there, Brian?
Exactly. Yeah. The prioritization of all of the, so I sit down and I say, okay, I've got 3 hours. I've got a window of 3 hours to go patch stuff. What's the first thing I should go patch?
Yeah. So we do have a decorator around the risk score, and we do input data into our risk score. I will say the one thing of risk scores is it's going to be, each company will have a slightly different model for risk scores, and I'm sure you have different inputs than another company that's the same size, even same vertical. It's so bespoke in that area. But we do our best to put together a risk score. So if you have essentially nothing and you need to start from zero, we do have that view in one of our decorators.
Yep. So I actually have it. I actually have it pulled up. Is we have a function that goes with our query language called a decorator, where we will pull in CVE information and actually lay it out for you on a device by device basis as you're looking on a hop by hop basis. So if we're talking about a hot path, right? If we're talking about a path to your ERP system or to the crown jewels of the organization, you have a bunch of devices that have critical CVEs in front of them. We lay it out in this way where we go, okay, this particular path, I may want to start remediating these guys first versus the one that may go to the management network or may go to, you know, some closet somewhere where there's something that no one's really talking that much about.
Yeah, and that bespoke aspect of things that you talked about was essentially going to be my follow-up question, which is how flexible and customizable this can be. So you talked about the crown jewels, the ERP type system.
Mhm.
Like again, a 7 on my ERP system and a 7 on, you know, the accounting system or some other random system that doesn't
Mhm.
have PII information
Mhm.
are going to be very different 7s.
Yep.
And so how much of that can you infer? How much of that can I as a customer input into the system so that you can do those calculations?
Yeah, so I can take some of that. So I think, so let's assume you have a well-labeled network. Everything's, you know, more or less up to date in terms of inventory. We have a very extensible interface, being able to write your own custom violations, your own custom metrics, your own reporting, alerting, whatever it might be. And you can basically just either write it yourself or use our community, which we share, you know, those types of things together with other peers, and put that in and make that applicable to your organization. A lot of our customers use it for niche compliance requirements, or maybe there's certain geographic requirements that you might have. All of that can be built. If it's not already built in the system, it can be built and imported into the platform. So that I think that hopefully answers what you're asking.
Yeah. Just to reflect it back to make sure I understand it, it sounds like it's got that flexibility, but it's not necessarily it doesn't come pre-built that way. It's kind of something that each customer would have to kind of build their own situation for that based on their needs and what they need to see in things.
Yeah, I mean, we have the basic standard kind of what we assume is a risk score. We make a couple of assumptions, we lay it out, but you're right, it's only one, and it's kind of the generalized approach. And if you need something on top of that, then you will have to build it yourself and import it. And actually, Mike's going to go into some of that with the last demo, and hopefully that'll bring some more clarity around it.
Before we get into the last demo, this is Richard real quick. How much of the custom reporting and the custom configuration of this product that Brian just kind of alluded to is actually necessary on day 2 operations? You get it in, you get it set up, you've purchased it, you've got your account team ready to go. It's talking to all your, you know, switches with sign-on and firewalls, and great. But what else does the customer of your product need to do to be able to utilize what we see on screen right now?
Yeah, I mean, it kind of, let's see, Mike had some slides, but basically we have verticals of customer use cases, and it might be depending on, you know, who you are and what you're using the product for. Out of the box, this is, I mean, more or less, as soon as it's set up, this is what you see.
What you see is what you get.
Yeah, you can run any query. It's got all of this data. You need to run a collection, so you need to start with one collection. So it'll take, I don't know, a couple hours depending on how big your network is, and then everything is ready to go. So none of this is customized here. This is all automated data collection. It's really, yeah, that other part was more the risk management part if you have certain things that you need to layer on top, but all of this is out of the box.
When you start looking at what we do with our query engine and being able to do stuff with decorators, that there's pieces to that there's somewhat of a there's somewhat of a learning that has to go into them, but everything we've shown till now is straight out of the box.
Yeah.
Fantastic. Thank you.
Mm-hmm.
I'm interested in seeing kind of a little bit more around the remediation side of it. Like, what capabilities are there? You know, it looks, you know, like some really solid aspects of being able to, as you said, kind of out of the box, get a good visualization of the network, quickly identify some of those vulnerabilities with the options to then customize to, like you said, any kind of niche use cases you may have in your org. But what about kind of the, you know, beyond the alerting? Hey, I know there's a problem. Are there mechanisms or integrations to help kind of accelerate or automate some of those fixes? You know, kind of in your example, if I've got 79 or 100 devices that are impacted, is there some way of automating it through your tool to apply the fix, or is it kind of stop just at the here's the problem, here's what you need to do and fix it, now go fix it kind of thing?
Yeah, so I can answer that one. So there's limited access to our platform is mostly deployed as read only. So what we've seen in terms of success is being able to connect. We allow for external connections, so we can kick off workflows based on certain alerts or certain configurations that trigger a downstream option. It might be a CI/CD. It could be even just a human process, or it could be a Slack message. Basically, figuring out what your workflow is, we can integrate into that so that action can be taken. And then I think as far as the remediation part, so there's two parts. So one is we've got upgrades, patches, you just need to update to the latest version. And then we've also got config changes. So making modifications to config, we basically have all of that data. So we know what to send so that the action can, has enough detail to actually be actionable. I think that's one of the parts with alerts is, sometimes it's just, do something. Well, what do I do? But being able to be very prescriptive in what the action you need to take, I think is super important. And that's something we can provide.
Yeah. So think of it as a platform that says, hey, listen, this is what the problem is. So if you're take one of my use cases, take a change management use case, right? We could actually integrate, and the integration that we do, right? We'll take a snapshot, we'll look at our snapshot, then it'll actually launch the change. And then it'll take another snapshot after the change, and it'll compare the two. And if it sees a diff, or if it sees intents start failing, then you can tell that engine, hey, listen, if we start seeing intents start failing, then we need to roll back. And then we could, examine what exactly happened. This is Forward is a read-only platform in that way, but we do, as Matt was saying, integrate with other things, but we're that kind of source of truth, per se, when it comes to changes that go around.
And that last demo, I think, will be exciting for a lot of these questions. We kind of wrap it up with this last demo that I think will blow your minds a bit. But yeah, we'll get there in a second.
No stress. All right. Any other questions? All right, cool. So the second to last demo.
Oh, did I?
Yes.
Okay, sorry.
So we talked a lot about how we can do path searching, how we can look at things, how we can enrich security in a certain way. Did a lot of stuff at layer 4. We had a question where it was like, oh, how high up can you go on the stack? So we can, if firewalls are configured for it, we can pull back URLs and we can search for specific URLs that users are hitting. If you have user identity built in, we can also search for user identity as well, so you can see that. So for instance, if we're going to go from SSH1 to WebVM1, and then I'm just going to throw a random app ID in here. So we're going to go app ID of SSH. All right, so we see we have 8 paths for this specific thing. I mean, yeah, that's cool. But if we go down to the filters and we start looking at the layer 7 attributes that we can filter on, we can also look at users. So if you have a set of users who should never be able to access something, but somehow they got through something, right? You just want to make sure that certain users can never access certain things. You can also see, okay, let me add Mike to this. How many paths does Mike have to this? Or write an intent check. Say, hey, listen, Mike, from here on in, if we see him accessing this, it's a problem. Mike shouldn't be accessing this particular thing, or Mike shouldn't be doing this. You can kind of get an idea of what your users are doing at any given time, as well as you can do a blanket search on user ID. So if you think a user was compromised, so we're going to go from anywhere. User ID, Mike. So right now, during this snapshot, I hit 2,077 plus devices. That may not look right. And it may be something that an incident response team may want to look into, like, why is Mike ping-ponging around? Was Mike's account compromise was this, did like this happen in Mike's account, and you can set all stuff like this through intent checking and all that as well.
Yeah, super powerful.
All right, and now I think the part of the demo that everyone's waiting for is our query engine. So everything, I'm going to try to keep this as high level because this could be a 4-hour conversation on its own. So essentially, when we capture the data, whether it be state data or config data, we normalize that and we throw it into one of our data, and we actually throw it into our data model that you can actually search on the right-hand side of the screen and look exactly at what you're looking for. So you don't need to be an expert out of the box to know what you're looking to do. You just need to know what's the end goal. What exactly am I looking to do to be able to report on this? So if I wanted to look, for instance, at all of my cloud security actions and kind of see what my ingress rule actions are, if you click this plus sign, it gives you a boilerplate code to throw in.
Yep.
You can throw that code in, you can see what you get out of it, and then you can massage it as you want, either by going through forwards documentation. As Matt was saying on the communities, I authored a bunch of NQE videos that will help walk through all this. But the two queries I want to show is rogue device detection. So I wrote a query to look for specific rogue devices inside of the network, and I have it set to do a violation. So if we added this particular query to verify, which is part of the intent checking piece, what would happen is every time a snapshot is run, it'll look and be like, oh, these specific vendors that are being looked for are present, and we're going to flag it either with an email or we're going to send a ServiceNow ticket. So if I run this.
Yeah, and let me walk through a use case, right? So let's imagine you're a global network. You need 100% uptime. Someone maybe in a remote office, maybe they needed to grab a quick device, something failed. Say, hey, I just need a new switch. Let me just grab a new switch. Go to the local market, bring it on, plug it in, network's back up. We're good. All right.
Because we don't see that in the real world.
Yeah, I mean, you do what you have to, right? And sometimes that, yeah, you know, it's hard to catch, and it's definitely something that doesn't get cleaned up super often. So if your policy is, hey, listen, we're only running approved devices, and we're only a Cisco shop, so we shouldn't be seeing anything else. Let's do this quick search, and Network Query Engine. I mean, it's really easy to use. It's basically for each device with some variables, select, and all of this. You know, we have pre-written stuff. We have a whole lot of documentation, but that's all it is. It's basically kind of a modified SQL language, and you're just saying, hey, run this. And then you can turn this into checks. So I just want to add that context.
So you could look through our library before I go through this, so you can see what you're looking for. If there's something specific and you want to modify it, all you have to do is just copy it, that it could come down. So this one is looking specifically for, it'll violate if I see any vendor from the OUI assignee that matches Huawei or matches Meraki. And then when I filter on true, we see that there are these specific devices. So we have actually, let me collapse this a little bit. So on this access switch on port 4, we have a Huawei device. On this access switch on port 5, we have another Huawei device. Then on this access switch on port 7, we have a Meraki device. So now you have the data that you need to be able to go and say, hey, listen, why is this here? Why do I have a Cisco Meraki hanging in some data center closet somewhere, or why is Huawei anywhere inside of my infrastructure? Then the second one is anyone who's managed an ASA kind of knows or at least I did back when I used to manage them, is keeping track of your allowed management subnets across your entire estate. There could be troubleshooting. There could be stuff where people will just randomly add IP addresses to be able to say, oh, I can't log into ASDM from here, or I can't SSH from this jump post. You know, I'm going to add something to see if I can get around that to do something, right? So what we have is a list of approved, company-approved management subnets. And then we have our query that's saying, hey, if you see something show up, it's instantly a violation. And it's so extensible that in your select statement, you could return whatever you want.
Yeah.
So in this specific select statement, what I'm doing is I'm going to return the violating configuration, and I'm also going to return the command to fix the violating configuration. So now a help desk guy can be empowered that someone someone either in security engineering or network engineering, whoever owns the firewall, wrote this query to assist to have someone fix it. And it's very basic. There could be a lot more to do to be able to fix it, to get the stuff off the higher architect's plates. But when we run this, now we see that there are a bunch of ASAs that are not in compliance to standard configuration. It tells you what the violating subnet is that's being allowed. It tells you the interface that it's configured on to accept connection on. It tells you what that violating configuration is, and then in plain text tells you how to fix it. Now, you may have noticed that there's a lot of blue and some black text in here. All the blue is clickable. So if you want to click it, it will take you right to that version of config, so you can see exactly where it is. Or if you wanted to see that device, like, hey, where is ATL Edge Firewall 01? It'll say, oh, this device sits here, and it starts glowing in the lower left-hand corner of the screen. So not only are we giving you the data, but we're giving you the links between the data to show you where it came from, and then show you if there were any specific cards on this pane, specifically with some of the stuff we can do with the NQE decorators, like CVE by device. Then you get all that information right in the palms of your hands.
One of the questions that I sometimes get asked is, we've identified this device or something, where is it? And whenever you guys have been showing your maps, you've been showing the interconnected networking devices. But what about the client devices, right? If it's an access switch that has, dozens or hundreds of workstations connected to it, I need to know what's on those. So can you guys kind of go through that? When someone asks the network or the security team,
Yep.
I'm looking for this device.
So Tony, when I used to do engineering, that was one of the least favorite things I used to do. So let's jump into one of our switches. And if we hit the details, right, we can see that if you look for the specific switch, it'll tell you all the hosts that are connected to it, MAC address wise and all that. The second piece of that is if you knew what you were looking for. So if you were looking for a specific IP address, or if you were looking for a specific MAC address and you didn't know where it lived in a data center that has, a couple thousand switches, all you have to do is come to the search bar, type it in. It'll tell you where it lives. It'll tell you the port, it'll tell you the VLAN, it'll tell you everything about it. Same thing with the, like vulnerabilities and all that. But because we are also getting stuff from what we learned about the network, we'll show you what the active NAT entries were at this point in time, what interfaces, what ARP entries, what routes, as well as what ACL rules are coming into play. So if you're doing a firewall decommission, and you don't know where this host could potentially have lived on any firewall, right? You can search for it, and then you can see the rules that are associated to this firewall. The rules that this host are associated to. So now you can properly clean up, rather than when you deploy a new host with the same IP address, now he's got a MySQL profile than having an Nginx profile.
Wow, that's actually something that I wish you would have opened with that an hour ago. Cleaning up firewall rules, having that visibility across the landscape of firewalls is really cool. Awesome, guys.
That's one of those split use cases. And we were torn about, are we going to show it here? Is it more networking? And the security guy is going to throw up pitchforks because the networking guy wants to talk about this. So we were hoping we were going to get a question like that. Thank you. And yes, it's a full text search. So not only can you do that, but do you want to see where specific VRFs live? So, and as you can see me typing, it's kind of like auto-suggesting what it thinks I'm looking for. So if I go to ecom1 prod, it'll tell me where it lives, the active interfaces, the routes, the ARPs, and actual text matches from the config of where this is configured, as well as if you look on the topology, they're all blue. So everything that lives in ecom1 prod is blue. And then drilling down further, we'll show you interfaces that are configured for it, so on and so forth.
I think I understand how this is broadly applicable to a lot of the disciplines within the secure, or a lot of areas within the security discipline, and how you guys are ingesting text-based configs from networking devices, firewalls, routers, switches. You have it, as well as many show commands. That's great. I think I understand kind of how you guys have built a little bit of the model to be able to depict the flow between devices using routes and ACLs and everything else. But what about when there's more complex network access requirements, such as some of the things that we see in zero trust network architectures, where they're using things like the disposition of the laptop, the time of day, your position in the company, and the sensitivity of the data access. All of those things can be values in whether or not you are able to access that data or that resource, that workload that you are trying to access. How can something like those variables be plugged in here to be able to see whether or not someone has accessed or could access, or maybe is having trouble accessing something with so many other variables that aren't stored within the networking devices themselves?
So the forward platform as itself, right? What we collect from is we collect from layer 2 through layer 4 packet pushers, as well as AWS, GCP, and Azure. We do have an API that if you wanted to kind of take what we have, write an API, and then go into like another tool to do that correlation. We have customers that are doing that today, that they're using this as the source of truth, and then they're taking API data out of our tool, feeding it into another tool, so then they could make correlation based upon that.
Yeah, and let me answer it a slightly different way. I think there's, first of all, yeah, as Mike mentioned, this is a platform. And this is really, I mean, I think we're just getting started. There's a lot of stuff that we want to layer on top of this platform. We want to build more integrations, more features, more enhancements, especially in the security realm. And you saw a lot today. We've got a great roadmap in the future. So we're going to continue to develop on top of this. I think for some of the zero trust, being able to integrate with cloud is going to be already a key part of that, and understanding security groups, LANs. I think fundamentally, in order to have a strong zero trust type model, you need to have a good networking understanding, knowledge, asset management. All of that, I think, is the starting point. And then with that, we can layer on top of that more and more in the future. So I think I'll say that I think that there's a lot of work that we will be doing, and a lot of work that can be done today. I mean, we have an extensible platform. So Mike mentioned APIs, configurability, NQEs, integrations, Jira tickets. You know, there's a lot of stuff we have, and we can allow for parallel development. But you know, I think some of this will be native in the future.